So I want to go through a couple of parts of assignment number 5, and hopefully it'll help some of you folks get started and do them in a more efficient fashion. So first I want to start out with problem number 2, and problem number 2 gives 3 different schedules, A, B, and C. So we're going to look at the schedule that's labeled A, and we're going to try to answer the question that's labeled number 2, which is that any possible schedule that for those transactions will be a conflict serializable schedule, okay? And if there's no deadlock. So here are the 2 schedules. The 2 transactions. And so we're going to look at as any possible schedule for these guys that won't result in a deadlock and respects all the current locking in those transactions. So the first thing to notice here is that these data item C has that's accessed or written to in transaction 1 is not at all in transaction 2. So it's largely irrelevant. It doesn't really matter. So in fact, what we can do is simplify things down to these 2 transactions. So I haven't changed the ordering of anything. All I've done is gotten rid of these first 2 statements. Okay, now we're going to look at 2 cases. Let's suppose the schedule, a proposed schedule, is one where T1 goes first. Well, if T1 goes first, that means the very first thing that's going to happen is A is going to be locked. So A is going to be assigned for T1. But then 2-phase locking basically says that A can only unlock after its commit, right up here. So what does that mean? Well, that means that transaction 1 is going to basically own A for the whole time that it's running, and that now transaction 2 won't be able to access A until T1 finishes. But moreover, what's also important is that T2 can't access B until T1 locks B, because otherwise there'd be a deadlock. So transaction 2 can't do anything with B until transaction 1 gets past here. Thus, any schedule where T1 goes first will mean that it gets to lock both A and B. And then that means that T2 can't execute any of its instructions until T1 unlocks A and B, which will be after T1 is committed. Clearly, the resulting schedule is conflict serializable since the precedence graph has got to be acyclic under those circumstances. So that's only if T1 goes first, but the argument's basically exactly the same if T2 goes first, other than the roles of A and B are reversed. So hopefully this gives you a little idea about how to go about these problems. You want to reason about the implications of the locks and what that does in terms of the schedule, and try to get it to satisfy the condition that the problem is asking about, in this case, conflict serializability. So now the question is, will any schedule be recoverable, be a recoverable schedule? Okay, we're going to work on the same 2 transactions and reason about that. And we're going to reason about it pretty much in the exact same way. First, note that any interaction in T1 on data C is irrelevant because it's not even in T2. So there's certainly not going to be any dependence if for instance, if T2 were to abort. So anyway, we have these 2 simplified versions, and since we're using locks, and both transactions do not unlock a data item until after they commit on the transaction, right? It's clear from that, if you go back to the definition of a recoverable schedule, that say TJ, suppose that was T2, can only read in a data item previously written by T1 if T1 has already committed. Well, that's exactly what the locking does. Namely that TJ can only read a data item after T1 or TI has unlocked it. So this one's pretty straightforward. Finally, now we'll look at again at the same schedule, but now we're going to look at it for whether all the possible schedules that respect the constraints here will be schedules without a cascading rollback. So again, just as in the last two cases, whichever transaction T1 or T2 locks A or B first, then that's going to carry through because the schedule can't have a deadlock in it. By carry through, I mean the other the other transaction basically won't be able to do anything until the first schedule completely commits and unlocks the data. So that implies in either case, if a transaction aborts, whether it's transaction 1 or transaction 2, the other transaction will not need to be rolled back since there is no dependency from the instructions that had executed before the rollback occurred. Hopefully you found this helpful. Good luck on the rest of the assignment.